Welcome to the Chapter 12 lesson. In this chapter, we're going to be talking about solutions, how they're made, what the different definitions of solutions are based on the size of particles in them, and also um, how the concentrations, how we can find the concentrations. In this first section, we'll be looking at electrolytes versus non-electrolytes, solvent combinations. There's three types we're going to define. And then those are the suspensions, colloids, and solutions. First off, we want to define soluble, which means it's able to be dissolved. As you know, some things like sugar dissolve quite easily when you have water, for instance, but then sand does not dissolve very well at all. The sugar example would represent a solution. Solution is a homogeneous mixture where two or more substances are in a single phase. We would just look at that substance and recognize one substance. We wouldn't see two different layers like you would with oil and water, for instance. That would be two phases. A solution would be just one phase in that sense. When we dissolve something, we have a solvent, which is the outer portion of the solution, basically what's dissolving the solute, and the solute is, of course, the thing being dissolved. So in the sugar water example, the water would act as the solvent, and the sugar would be dissolved within the solvent. It doesn't always have to be water for the solvent. It can be other liquids as well, or even solids like alloys. We have solutions, for instance, of brass is a combination of two metals combined in an alloy, zinc and copper. And then sterling silver is made from a certain percentage of silver and copper. As you can see in these diagrams, you have the different molecules that are dispersed throughout the solution. So the first type of mixture here we're going to talk about is a suspension. In this case, the particles are so large that they're going to settle out of the mixture. You might think of orange juice with pulp. You see the pulp settling. It's visible to you. Or a jar of muddy water. When you see the thing settle out and it's visible, that's when we have a suspension. The definition in terms of size of the particle would be anything essentially visible, which is over 1,000 nanometers in diameter, so 1,000 times as large as atoms. A colloid would be something that is in between a solution and a suspension, so the particles are small enough to be suspended throughout, but if we look really, really closely, we can see if we zoom in, essentially, if we look at it on a microscopic scale, you'll see the particles are not fully dissolved, and there's different tests we can do to be able to tell if we have a colloid. Mayonnaise is an example of this, being oil droplets in water. There's this effect called the Tindle Effect, where if we are not sure if a substance is a solution or a colloid, we can shine light. For instance, when we have a headlight beam shining through a fog, we can see that beam because the fog is a mixture, essentially a colloid. We see the different particles when we shine the light through it. It becomes foggy. So that's how we can distinguish. If you look at these two different solutions on the left, it's not a colloid if I shine the light through and I don't really see the beam of light, but you can see on the right there how I see the beam of light through the liquid. That's what can tell me that it's a colloid. And just so you can see everything in the chart, so we can compare, solutions would be the only homogeneous one of the three. Colloids and suspensions are both heterogeneous. And remember, solutions, you have the particle size dissolved so small that it's less than a nanometer. Suspensions, the particles are so large you can see them, and then colloids are kind of in between. It can be hard to tell that a colloid's not a solution. Again, that Tindle effect will help us to distinguish between a colloid and a solution. Because notice that both colloids and solutions cannot be separated by filtration. The particles are too big to filter out, whereas suspensions, we can filter them out because the particles will settle. So now we want to talk about electrolytes versus non-electrolytes. Electrolytes are substances that dissolve in water to allow the solution to conduct electric current. So sodium chloride would be an electrolyte. Any soluble ionic compound would be considered an electrolyte because those positive and negative ions will separate from each other and they're free to move, allowing that current to pass through the solution. On the other hand, substances like sugar would be classified as a non-electrolyte because even though they dissolve in water, they don't allow that solution to conduct electricity. So these are neutral solutes that don't contain those charged particles and thus aren't conducive to electric flow.